Welcome to the third lecture of linear programming. In the last lecture, one numerical was given as homework for the self-assessment. I am repeating the statement that a company manufactures two different types of product A and B. Each product is processed by the casting, machining and inspection. The capacities of this department are 45 hours, 35 hours and 30 hours per week. Product A requires 10 hours in casting, 12 hours in machining and 6 hours in the inspection. For B, it is 7 hours, 6 hours and 8 hours. The profit contribution of A and B is 50 rupees and 40 rupees respectively. Formulate the LP problem. So, the solution is here. Decision variables will be in this case x1 and x2. x1 are the quantities manufactured of product A. x2 are likewise the quantities manufactured of product B. In this case, objective function will be of maximization type, maxat, that is 50x1 plus 40x2. There will be three constraint equation for the three different departments. Very first will be 10x1 plus 7x2 less than 45 for the casting, 12x1 plus 6x2 less than 35 for the machining constraints, and 6x1 plus 8x2 less than 30 for the inspection, and non-negativity conditions are labeled as x1 and x2, both are greater than 0. Okay. Next problem, probably the last in the category of problem formulation. Here the problem statement is given as an advertising company wishes to plan its advertising strategy in three different media as television, radio and magazine. The purpose of the advertise is to reach the large number of potential customers as possible. Following data has been collected from the market survey. Very first is the cost of advertising unit. Means if advertising company wishes to broadcast and advertise, so per unit advertisement what is the cost? So on television the cost is 30,000, on radio it is 20,000 rupees. In magazine there are two categories, magazine 1 and magazine 2. For that this cost are 15,000 and 10,000 respectively. Second criteria, second survey, it is that number of potential customers reached per unit. Means if the single advertise is broadcasted on this different platforms, how many viewerships will be there. So for the television, per unit broadcasting viewers are 2 lakhs, for radio it is 6 lakhs, for magazine 1 it is 1,50,000 and magazine 2 it is 1 lakh. And third conclusion from the market survey is number of female customers reached per unit broadcasting, that is 1,50,000 for television, 4 lakh for the radio, 70,000 for the magazine 1 and 50,000 for the magazine 2. Further, the company wants to spend not more than 4,50,000 rupees on the advertising. Also, there are 4 other constraints, at least 1 million exposures should take place among the female customers. Second is advertising on the magazine 1 be limited to 1,50,000 rupees. Third, at least 3 advertising units be brought on magazine 1 and 2 units on magazine 2. Last, the combined numbers of advertising units on television and radio should be between 5 and 10. For this given information, formulate the problem. Okay. So we know that basically we have 4 variables in problem formulation. Very first amongst is decision variable, or decision variables. So in this case, what could be my decision variable? See, the cost is given. Second one could be number of potential customers. Okay, but suppose if I take cost of advertising as my decision variable, so here one of the constraints states that advertising on magazine 1 be limited to 1,50,000. Likewise, also one constraint is mentioned here that at least 3 advertising unit be bought on magazine 1. So if I am taking a cost as a decision variable, it cannot justify this third constraint, because here it is mentioned in a units. Okay, that how many units of advertisement should be published or should be bought on magazine 1. So cost does not justify that particular constraint. So here I will take advertisement units as my decision variable, because that is something that can justify all these constraints. So decision variable, here I am writing that let x1 are the number of advertising units broadcasted on television. X1 are the number of advertising units broadcasted on TV. Likewise, X2 are the number of advertising units broadcasted on radio. X3 and X4 are the number of advertising units published in magazine 1 and 2 respectively. So my decision variable is clearly stated here. Okay, that I have considered 4 decision variable in terms of number of advertise that can be broadcasted on 4 different media category. What is my objective function? Okay, so the objective function is mentioned here. Okay, that advertise should be reach as large number of potential consumer as possible. Okay, purpose is clearly mentioned here, that advertise is to reach large number of potential customers as possible. So objective function is of max type, it is of maximization type, max z. Okay, and the purpose is to reach the large number of consumers. If I broadcast one advertise on the television, corresponding to that it may reach up to the 2 lakhs people. If I broadcast one advertisement on television, but actually I am broadcasting x1 numbers of advertisement on television, so the reach will be 2 lakh into x1. So very first variable is 2 lakhs times x1 plus, likewise for radio it is 6 lakhs x2 plus 1,50,000 x3 plus 1 lakh x4. Okay, it is correct. Third are our constraint equations. Okay, very first constraint equation is mentioned here. The company wants to spend not more than 4,50,000 rupees on advertising. Means the total cost of all the advertise which are aired on television, radio, magazine and magazine 1 and magazine 2, the total cost should not be more than 4,50,000. So very first constraint equation is that related to this total cost is that 2 lakhs into x1. Okay, it is the cost, so pardon, that is 30,000 x1 plus 20,000 x2 plus 15,000 x3 plus 10,000 x4 is less than or equals to 4,50,000. Okay, that unit advertisement cost on television is 30,000. Actual quantity which are broadcasted that are x1, so 30,000 into x1. Likewise for radio 20,000 x2, for magazine 1 it is 15,000 x3, and for magazine 4 it is 10,000 x4. This total cost should be less than 4,50,000. Okay, moving further. Next constraint, at least 1 million exposure should take place among the female customers. So for that the second constraint equation should be written in this way. For female it is mentioned over here, so 1,50,000 into x1 plus 4 lakh into x2 plus 70,000 into x3 plus 50,000 into x4 should be greater than or equals to 1 million, 10 lakhs. This is the second constraint equation. Means it is related to female consumers. Next, advertising on magazine 1 be limited to 1,50,000 rupees. Means the total spend on magazine 1 should not be increased by 1,50,000. So for a unit broadcasting the cost is 15,000. How many we are broadcasting? x3. So the total cost is 15,000 x3 is less than or equals to 1,50,000. This is the third constraint equation. 15,000 x3 is less than or equals to 1,50,000 rupees. Next, at least 3 advertising units be bought on the magazine 1 and 2 units on magazine 2. Yes, what it is mentioned, third one, at least at least 3 advertising units be bought on magazine 1. So x3 should be greater than or equals to 3. Okay, x3 are the number of units of advertisement those are broadcasted in magazine 1, so it should be greater than 3, and 2 units on magazine 2, and x2 should be greater than or equals to 2. So this satisfies the constraint number 3. Fourth, the combined numbers of advertising units on television and radio should be between 5 and 10. The combined numbers of advertising units of television and radio are between 5 and 10. So 5 is less than or equals to x1 plus x2 is less than 10. This is the constraint equation for the television and radio. Okay, and last, fourth number, that is non-negative conditions. So that is x1, x2, x3 and x4 is greater than or equals to 0. Okay, this is how we may formulate the problem from the descriptive analysis. Moving forward, now we have to discuss that how we can solve the mathematical equations which are formed from the descriptive information. So second part is the solution of mathematical equation, means it is related to that how to solve linear programming problem. So basically there are two methods available. One method is referred as a graphical method for solving linear programming problem, and second method is referred as simplex method to solve linear programming problem. So these two methods are used in different categories. When the number of decision variables are less than 2, less than or equals to 2, in that case the graphical method should be used. Okay, because we know in graph we have only two axes, x-axis and y-axis. So when we have two decision variables, 2 or less than that, only in that case the graphical method can be used. Whenever the number of decision variables exceeds 2, means when we have 3, 4, 5 and up to n numbers, so for solving those type of linear programming problem we must go for a simplex method. Okay, graphical method can be used when we have 2 or less than that decision variables. Whenever it exceeds that value, after that we must go for a simplex method. And today we are going to discuss that how to solve a LPP model using graphical methods. So here I am taking the very first numerical using graphical method. I will try to solve it. Here it is mentioned that use a graphical method to solve following LPP. This information, this mathematical equations are formulated from the descriptive information. So it may appear that you require to formulate a problem and then you require to solve it using a graphical method. So that type of combined question can also be generate it. Okay. So objective function here it is given, it is of maximization type. Attention should be given to the type of objective function when we are solving using a graphical method. This one is of maximize type. Function is that max z equals to 20x plus 45, and it is subjected to constraint equations. 1.5x plus y should be less than or equals to 750. X plus 3y should be less than or equals to 900. X is less than 450 and y is again less than 250. Four constraint equations are given to us and non-negativity conditions are mentioned here again. So what is the first step while solving LP model using graphical method? The very first step is that this all constraints limitations what I have here, less than or equals to or maybe greater than or equals to, those are required to be converted into equal to functions. Means I require to write simply this equation in the form of line 1.5x plus y equals to 750. X plus 3y equals to 900. X equals to 450 and y equals to 250. This is the first step, that inequalities are converted into equal to form. So these are the equations of line. Now I require to compute that on the x-axis and on the y-axis at which particular point this line intersects. Okay, your horizontal and vertical primary axis that you have on a graph paper. So at which point, okay, on both the axes this particular line is intersecting, I require to compute that part. So if I am taking y part as a 0 in this line equation, I can get the intersection of this line with the x-axis. Okay, I am assuming y part as a 0. So if I assume here this y part as a 0, so 1.5 times x equals to 750, means 750 requires to be divided by 1.5. So that will give me an answer of 500. So intersection of this line with the horizontal axis, it is 500 and 0. Likewise for this x plus 3y equals to 900, y I have to assume as a 0. So x equals to 900, intersection point is 900, 0. X equals to 450. This is a line equation in which the y component is 0. So this will intersect with the horizontal axis at 450, 0. Okay. If now I am taking the x part as a 0, if I try to take the x part as a 0 in this equations, so this part becomes a 0, 1.5 into 0, that is a 0. So the value of y is 750. So this become 0 and 750 for this one. X as a 0, so y gives you 900 divided by 3, so that is 300. So 0, 300. And this equation, this line equation, it intersects at 0, 250 point. So this is the second step. Very first step is that inequalities are converted into equal to sign. Second is that you require to identify the intersection of these points intersection of these lines with your horizontal axis and vertical axis. After doing this much, it is essential for us to use a graph paper. On graph paper I have two axes, one is my x-axis and second one is my y-axis. I have to plot this many points, okay, that I require to plot these lines. So for plotting this many points, I require to assume my scale. So I am writing my scale here. For x-axis, 1 centimeter equals to 100 units, and for y-axis, 1 centimeter equals to 100 units. I have taken this scale. Now if I require to plot my first line, this 1.5x plus y equals to 750. So it intersect at these 2 points, 500, 0. I require to write my scale here, 100, 200, 300, 400, 500, 700, 900. Likewise on vertical axis, 100, 200, 300, 400, 500, 600, 800 and 900. I require to plot this line. It is intersecting at this 2 point. Very first point is 500, 0. 500, 0 is this point. And second is 0 and 750. 0, 750 is this. I require to connect this 2 dots. I have connected these 2 dots. And now I require to see again this sign. The sign is less than or equals to. Okay, this is the equation of this line. Now I have to pay attention to this particular sign. The sign over here is of less than or equals to type. So what I need to do is that now here I require to draw 2 arrows in this direction. It is very essential to show these arrows. As such, it states that this x and y combination should be less than or equals to 750. So this side below this particular part, it indicate that this line equation satisfied that condition, it is below 750. If the equation given to here, if it is 1.5x plus y is greater than or equals to 750, in that case I require to show an arrow in this direction. It shows the above this particular line. You require to satisfy this constraint equation. However, here it is less than or equals to, hence I have mentioned in this way arrows. It is very essential to write the equation of the line. So here I am writing 1.5x plus y equals to 750, this line. This information is mandatory to mention. Second line, x plus 3y is less than 900. What are the points 900, 0? So 900, 0 is this point, and 0, 300. So 0, 300 is this point. Again, connect these 2 dots. The sign here is again of less than or equals to type, so arrows in a downward direction. So arrows in a downward direction. the equation of line for this one, it is x plus 3y equals to 900 line. Third, x equals to 450. This is a vertical line, point is 450, 0. So 450, 0 is this point, and it is a line that is parallel to y axis. So 450, 0. Arrows again in this direction, as the x quantity is less than or equals to 450. Hence, the arrows are shown on the left hand side. This line is x equals to 450, line is parallel to y axis. And the fourth line is y is equals to 250. Y equals to 250, and the point is 0 to 50, that is here, 0 to 50. And if I try to plot that line, so 0 to 50, again the sign is less than or equals to, hence the arrows in a downward direction. So this is the equation, the line y equals to 250. It is fine up to here that we have plotted all the lines on your graph on the x-axis and y-axis. See, the first line equation states that the combination of x and y is less than this, means this is a feasible region, means your value should lie below this, the constraint equation. The second line states that the combination of x and y should be less than this. Third line states that the x should be less than this, and the fourth states that the y should be less than 250. So what is the feasible solution? What is the solution of this graphical method? That intersection of all this line, or the common region of all these boundaries, the common region of all these boundaries is considered as your feasible solution. It is considered as your bounded region as well. See, the common region of all this, the region below this, the region below this line, it is all this region, it is all this region. But what we have is that we have a non-negative conditions. We have non-negative condition that your x and y should be greater than 0. Means in the second quadrant, third quadrant and fourth quadrant, either the value of x or the value of y or the value of both x and y is less than 0. So those compartment cannot be considered in a study. Those quadrants are not part of the graphical solution, because in non-negative condition itself we have stated that the value of x and y is always greater than 0. So the region below this line in the first quadrant is this triangle. This is the feasible region that satisfies your constraint equation 1. Likewise, the feasible region for the constraint equation second, x plus 3y equals to 900. So the feasible region is this one. The feasible region is this one. For the third one, likewise, this entire region, in a vertical direction it is moving infinite. Likewise, for the fourth one, the region below this line is feasible region. So what is the common region of all this? What is the common region of all this? So the common region for all of this is this one. If I am drawing that using a hatch line, so this is the common region, see, of all these lines. This is the common region of all these lines. Yes, this region satisfies the condition of line 1, but it does not satisfy the constraints or limitations of line 2, hence it is excluded. Likewise, for all these 4 lines, the common region is this one. So this is referred as your bounded region. This region is referred as your bounded region because it is forming some shape of polygon. It is enclosed totally. We cannot go beyond this in the second, third and fourth quadrant because of non-negative condition. So this is my bounded region. Now in this bounded region, how many points do I am getting? How many points I am getting of this polygon? See, 1 point I am getting here. I am labeling it as a A. Second is this point, this one, that is B. Third one is this, that is a C. Fourth one is this D. Fifth I am getting over here, that is my E. I have got 5 points. Even I got the 6 point F, but that is a origin. Okay, origin will give me a value of 0, 0. So totally I have got 6 point of this polygon A, B, C, D, E and F. Now I try to write all these points. Okay, A point. What is the point A location? It is 250 on the y axis and 0 on the x axis, so it is 0, 250. What is the B? B is getting you 150 and 250. On the x axis it gives you a 150, on the y axis it gives a 250, so 150 and 250. C gives the value as such of 400 on the x axis and somewhat $170 on the x axis, 170 and 400 and 170. The D gives the value as such 450 here and 80 on the y axis. E gives me the value of 400 and 0 and F gives me a value of 0, 0. This many points I have got from the solution A, B, C, D, E. So out of this 4, out of this 6, there is only a one optimal solution. This all gives me the value of feasible solutions as per the definition that I have discussed in the first lecture. This all 6 combination gives me a different feasible solutions, but I require to compute the optimum solution, the best solution. So for that, what I need to do is that I require to put back this values into the objective function. What is the objective function? It is a max z 20x plus 40y. So if I put the values of A into this equation, so 20 into 0, that is 0, 250 into 40, so 250 into 40, that gives me a 10,000. Okay, it is 10k. Next is this, so 150 into 20, so 30 here, 3000 plus 250 into 40, so that is 10,000. So it gives me a 13,000 value, 13k. C 400 and 170, so 400 into 2, that is 8,000 plus 40 into 170, so that is 170 into 40, that is 68 into 0, 6800. So the total of this two, that is I am getting as a 14,800, 14.8k for the D, 450 and 80. So 45 into 2, that is 99,000 plus 80 into 40, that is 3,200. So this gives me a 12.2k. E, that is 400 into 20, so this gives me a 8,000, 8k, and F, that gives me a 0. See, what is the function? Function is to maximize. I require to maximize the profit, and the profit maximum I am getting at this particular combination. For the ZC, I am getting the maximum profit. Hence, I should select the value of X and Y in a such a way that X should be of 400 magnitude, Y should be of 170 magnitude. This combination satisfies all these constant equations, and it gives me the best highest value. It gives me the highest value. Hence, X and Y value should be selected as a 400 and 170, and corresponding the maximum profit is 14,800. One more numerical to the graphical method. Solve the following LPP using graphical method. The function here is of maximization type. Max Z equals to 2x1 plus x2, subjected to 4 constant equations. x1 plus 2x2 is less than equals to 10, x1 plus x2 is less than equals to 6, x1 minus x2 is less than equals to 2, and x1 minus 2 times x2 is less than or equals to 1. We know how to solve LPP model using graphical method. The first step is that inequalities are converted into equal to signs. So I am rewriting this equations. X1 plus 2x2 equals to 10, x1 plus x2 equals to 6, x1 minus x2 equals to 2, and x1 minus 2x2 equals to 1. First step is clear. Next, I require to compute the intersection of these lines with the x-axis and y-axis. To compute the intersection of these lines with the x-axis, I require to take y component as a 0. So I am taking y component as a 0. So if I take the y component means x2 as a 0, so intersection of first line, that is x1 plus 2x2 equals to 10, x2 is 0, so x1 equals to 10, intersection is 10, 0. Second, x1 plus x2 equals to 6, so x1 plus x2 equals to 6, hence it is 6, 0. If I take the x2 as a 0, here again if I take x2 as a 0, x1 equals to 2, so 2, 0. Here again if I take x2 as a 0, so x1 is 1 and 0. To compute the intersection with the y-axis, x component I need to take as a 0. So if I take x component means x1 as a 0, value of x2 is 5. Here it is 0, 6, 45 degree line. x1 minus x2 equals to 2. So if I take the x1 as a 0, x2 gives me the value of minus 2. Here if I take x1 as a 0, x2 value is minus 1/2, 0.5. So intersections point are clear. I have computed the intersection points. Now I require to plot them on a graph. So this is our x-axis, this is my y-axis. First I need to write the scale. For x-axis the scale is 1 centimeter equals to 1 unit, and for the y-axis the scale is 1 centimeter equals to 1 unit. Scale is clear. For the first line the points are 10, 0 and 0, 5. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is my 10. Likewise here 1, 2, 3, 4, 5, 6, 7. Here it is -1, -2, -3. See, for the first line points are 10, 0 and 0, 5. So this is my 10, 0 and this is my 0, 5. Connect the dots. Dots are connected. What is the inequality sign? It is less than or equals to, means below this. The region, visible region is below this. It is clear. Now second. For second it is 6, 0 and 0, 6. This is my 6, 0. This is 0, 6. So 6, 0 and 0, 6. If I connect them, again sign is less than or equals to, hence that condition is satisfied. Third, that is 2, 0 and 0, -2. So this is my 2, 0 and x is 0 and y is -2. So this is my 0, -2. Yes, this is my negative y-axis. So x is 0 at this point and y is -2. So these two dots. So if I try to connect these two dots, line goes in this way. Now the sign is of less than or equals to, x1 minus x2 is less than 2. So which region do I require to consider? Means this arrows, do I have to show in this way, moving downward or moving upward? That is the case now. So what should I do? So if I randomly take 2 points, okay, if I randomly take 2 points, 1 point above this region and 1 point below this region, in such a way that the value of x1 and x2 should be greater than 0. So if I am randomly taking 1 point this, if randomly I am taking 1 point this, okay, at this point the x and y both are greater than and equals to 0, x1 and x2 both are greater than or equals to 0. So if I put this point in this inequality, x1 minus x2 is less than or equals to, so x is 0, this point is 0, 2. So x is 0 minus 2 is less than or equals to 2. See, if I am putting the point 0, 2 in this equation, so what it gives me, 0 minus 2 is still less than or equals to 2. Yes, the condition is satisfied. If I take any other point on the other side of the line, on the below side of the line, the point is 4, 0. This point is 4, 0. If I put this in the equation, what I am getting is 4 minus 0 is less than or equals to 2, which is not correct. It not satisfy the constraint requirement. So this region, below this line region, is not satisfying the constraint equation. Above this line region is satisfying the constraint. hence the arrow must come in a upward direction. That should be clear. Okay, last, what are the points for the last? 1 0 and 0 minus half. 1 0 is this one, x is 1, y is 0, and 0 minus 1 half. So x is 0 and this is minus 1 half is somewhere over here. So if I connect these two dots again, so this is the line. Now again, which region do I require to consider? Likewise, what I did in the previous, same I can do again over here. I can bifurcate two compartments, and if I randomly take this point, maybe 0 1, it is above this line. So if I put 0 1 in this line, where is the equation? Is here, 0 1, the point, this point. And second point, maybe if I consider 3 0. So if I am putting these two points in this equation, see what I get. x1, that is 0, minus 2 times x2, means minus 2 into 1, that is minus 2. So answer is minus 2, that is less than 1. So it satisfies the condition. If I take another point, 3 0, so 3 minus x2 is 0, so 0, that gives me a 3, which is greater than 1, so it does not satisfy. So 0 1 point, this particular region is satisfies. So above this line, conditions are satisfied by taking positive values. So this region has to be considered. Okay, so what are the lines? This line 10 0, okay, that is for this one, x1 plus 2 x2 is equals to 10. This line is x1 plus x2 equals to 6. Second line, this particular line is for the fourth equation, that is x1 minus 2x2 equals to 1, and this one is for the third one, x1 minus x2 equals to 2. So what is the common region for all this? For the first line, this is the feasible region, x and x2, x1 and x2 both are positive. For second one, this is the feasible region. So the common region for this two line, x1 plus x2 6 and x1 plus 2 x2 10, the common feasible region is this. Now if I consider this two line, the common feasible region is this much. If I draw them using a hatch line, this is the common feasible region. How many points do I get here? This is my A point, B, C here, another point I am getting D, this is my E point, and this is F, A, B, C, D, E, F. If I write all these points, okay, A point has a quadrant of 0 5, B has 2 4 value, B has a 2 and 4. What is a C? For C, approximately I am getting x as a 3.9 and y as a 2, 3.9 and 2. For D, it is 3.5 and 1.6. I am writing 1.6 here. E I am getting as a 1 0 and F is 0 0. This many points I got as a common region for all these 4 constraint equations. Now if I try to put them in a function, So value of ZA, 2x1 plus x2, so 2x1 plus x2, so x1 is 0, x2 is 5, so ZA is 5. What is the value of ZB? So 2 into 2, that is 4, plus 4, that is 8. Yes, I am putting back these values into the function. Here 2 into x1, so 2 into 3.9, that is gives me 7.8 plus 2, so 7.8 plus 2, that is 9.8. D, 3.5 and 1.6, so 3.5 into 2, that is 7, plus 1.6, that is 8.6. E, that is 1, so 2 into 1 are 2, and ZF is 0. Okay, so all this A, B, C, D, E, F are my feasible solution, and my optimal solution, as it is a maximization type, maximum value I am getting with the C combination. Hence the x1 should be 3.9, x2 should be 2, and corresponding maximum profit is 9.8. I expect now maximization type are clear, how to select region is clear, and how to find the optimal solution for the maximization type is clear. So here I resume the lecture for graphical method. In third lecture I will again continue with the graphical methods.